Hello, everyone. Welcome to the oVirt network provider for OVN deep dive. The presentation will consist of 4 parts. First, a short overview of the Open vSwitch Open Virtual Network, OVN in short. Second, an overview of the oVirt external networks providers framework. Third, an overview of the oVirt network provider for OVN. And last, a live demo. OVN is an open source project that provides virtual networking based on Open vSwitch. OVN provides layer 2 and 3 virtual networking and firewall services for connecting virtual machines. It provides logical network entities such as logical switches, ports, routers, firewalls, and more. How does OVN work? OVN utilizes 3 items: a number of Open vSwitch OVS instances, open flow rules, and tunnels, which connect the different OVS instances to form one system. When we look at a single OVS instance, it connects all the ports connected to the OVS bridge. Here, all the ports connected to an OVS bridge can access each other. Let's now introduce open flows into the picture. OVN can be used with the open flow protocol. Open flow was created as a way of manipulating how packets flow within their network environments. Open flow controls network traffic by creating sets of rules called flow tables, which control how packets are moved within the system. For example, the rules below control how the traffic flows from port 1 to other ports on the system. We can see that the first rule specifies that all traffic from NIC 1 will be outputted to port 3. This is specified by actions equals to output 3. The other rules specify that all traffic to NICs 2 and 4 will be dropped. In effect, we can divide the bridge into 2 multiple isolated logical networks, the red network and the blue network. The next element is tunnels between different OVS bridges in an OVN environment. If we add ports to 2 OVS bridges and create a tunnel between them, packets from one bridge will be moved to the other, in effect, creating one big aggregated bridge. The entire OVN system consists of multiple interconnected OVS bridges, which work as a single bridge. Combining all this gives us the ability to create isolated logical switches spanning over the entire OVN environment consisting of multiple OVS switches. Here, for example, we would have 2 logical switches, red connecting NICs 1, 2, 5, and 6, and blue connecting 3, 4, 7, and 8. The OVN logical switches are the equivalent of oVirt networks. Whenever an external oVirt network is created, a logical switch is created in OVN. Architecturally, OVN consists of 2 layers. One is the OVN North, which is the central database of the system. The second are the OVN controllers, which reside on the hosts where NICs are plugged into the logical networks. OVN North consists of the OVN northbound and southbound database and the NorthD daemon. The northbound database contains the logical state of the virtual network. It holds information about the logical switches, logical ports, and all other virtual entities. The southbound database holds the physical state of the system. It contains the information about all physical hosts, In case of oVirt, these hosts will be our VDSM hosts. It also holds the location of the logical ports on the physical systems, the data path, and the logical flows. The North daemon monitors the changes made to both the northbound database and the southbound database, and in case of any changes either to the logical state of the system or its physical state, translates these changes into logical networking flows and updates the state of the southbound database. The OVN controller is a distributed network controller installed on each host. It monitors the OVN southbound database and configures the local OVS bridge accordingly. OVN connects all the VNICs by creating an OVS integration bridge called BRINT. Whenever a NIC is connected to this bridge, it must be in the system, it must be plugged to this integration bridge. Let's go over to the oVirt external network providers now. The external network provider's infrastructure allows to externalize the network implementation to an external party. Then external party can be anything like OpenStack Neutron, Open vSwitch OVN, or any other networking provider. Multiple external network providers can be added to oVirt. To add an external network provider, a new provider of type external network provider must be chosen in the external providers menu, and its URL must be specified. Each of the external network providers manages its own set of external networks. Networks can either be imported from the external provider, or new external networks for a provider can be created from within oVirt. An external provider will take over all management of external networks associated with the provider, as well as control of all the entities, such as ports belonging to these networks. The main reason for creating the external providers is to give the user more control of how networks are managed in the entire user environment. oVirt can very well control its own networks, but it's often only a part of a bigger networking environment. The user may want to have a single centralized network management system that controls all components in his environment in a uniform fashion. Another advantage of the external providers is that it allows the user to enjoy all the networking technologies provided by all the networking providers. The implementation of an external network provider consists of two parts. One is the provider to which the oVirt engine connects and interacts. The other is the virtual interface driver, VIV driver in short, which takes care of plugging and unplugging virtual NICs on VDSM hosts. Let's talk about the provider first. The provider is responsible for the administration of external networks and its related entities such as ports and subnets. It exposes a REST API, which allows the engine to create, delete, and modify networks, ports, and subnets. The information about the external entities is kept on the provider. The oVirt engine only keeps stub objects identifying the external entities. The REST API, which the provider exposes, is a subset of the OpenStack Neutron API. We currently use the latest version of this API, which is version 2. The supported subset of the Neutron API includes networks, ports, and subnets. The second element is the virtual interface driver. This element is located on each VDSM host. Its task is to plug or unplug the virtual NICs to the external networks. Whenever a request to plug or unplug NIC is sent to VDSM, VDSM uses the hooking framework to invoke an appropriate VIF driver hook. These VIF driver hooks implement the plugging of the VNIC to the external network. Looking at the entire plug-unplug operation, first, a user has to create an external network on the provider. To do this, the user uses the oVirt UI, from which a request is passed to the external provider. The provider in turn creates a network in the physical infrastructure managed by the provider. The next step is to create a port on this external network. The user does this by creating a VNIC on a VM. The oVirt engine issues a request to the external provider to create the port. The external provider creates the port, returning the port ID to the oVirt engine. The oVirt engine then proceeds to request a specific VDSM host to create a VNIC on a specified VM and plug this VNIC into the external network. The ID of the external port is included in the request. First, VDSM creates the VNIC on the VM. It then hands over control to the VIF driver hooks, passing the external port ID. The VIF driver is then responsible for plugging these VNICs to the external networks created by the external provider. Now that we know how OVN works and how external providers work, we can combine the two and talk about the oVirt network provider for OVN. The oVirt network provider for OVN is an implementation of the external provider, so it works just as was described a minute ago for the external network providers. The provider is a proxy between oVirt engine and the OVN northbound DB, which contains the logical view of the OVN network. All requests to the provider are translated into OVN database queries or updates. The virtual interface driver utilizes libvirt support for open vSwitch bridges. libvirt handles the connection of the VNIC to the appropriate open vSwitch bridge. In this case, this is the BR-int integration bridge, and notifies the southbound database of the changes in the physical infrastructure. The changes are then propagated by the OVN southbound database throughout the entire networking environment, informing all the other OVN controllers to update their networking flows accordingly. There are several advantages of using OVN-based networking. The most important one is that it allows to use a large number of networks with no need for multiple host NICs or using the use of VLANs. Networks can be created and modified without any changes to the physical infrastructure, and also the physical infrastructure can be changed without any effect on the logical networking in the infrastructure. Let's now talk about the oVirt provider installation and configuration. First, the prerequisites. The provider requires the following packages to be installed. On the provider, it's Python Open vSwitch and the OVN Central packages, OVN Central and OVN Common, as well as Open vSwitch. The provider does not have to be installed on the same host as either oVirt engine or the OVN northbound database, but these packages are anyway required to be able to connect to this database. For the virtual interface driver, we also need to have openvSwitch installed along with openvSwitch OVN host, Python openvSwitch, and of course, as the virtual interface driver is installed on the VDSM host, it also requires VDSM to be installed on the host. The OVN and O packages are not yet available. A description of how to build them can be found under the following link. This is the link that I mentioned. Getting the provider RPMs. Excuse me. At the moment, you can use the links shown above to get the provider and VIF driver RPMs. The second one should always point to the latest available version. Alternatively, you can clone the OVN provider repo and build the RPMs yourself. It's a fairly simple process. It's actually only the 3 commands listed here that will do the job. Building the RPMs yourself will require to have make and RPM build installed on your system. Having the RPMs downloaded, you can install them using YAM or DNF. Instead, in case of the provider, you will also have to enable and start the oVirt provider OVN service. For the driver, it's enough to install it since it is invoked as a VDSM hook. It does not need any processes to be running. The virtual interface driver will need some basic configuration. What we need to do is we need to connect the OVN controller to the OVN central database, specifically to the OVN southbound database. We also need to establish tunnels to the other OVN hosts. This can be done either by using the VDSM tool command. It's VDSM tool OVN config, the IP of the central server, and the IP of the local IP used for OVN tunneling. Alternatively, you can also update the OVS database directly and use the commands listed below. If you do the latter, you also need to restart all the open vSwitch processes. The firewall configuration. First, you need to configure the firewall for OVN. The details are described on the blog, the link to which is listed here below. For testing, you can always disable the firewall. For the provider, you will need to also open some ports in the firewall. A firewall service is prepared for this. To enable it, please add the oVirt provider OVN service to the firewall configuration on your system. Now, let us go to the live demo. Some of the OVN commands which I will be using during the demo and which might be useful when working with OVN. First, OVS vSCTL vSwitch control. This is the command for controlling open vSwitch bridges. OVN northbound control NBCTL. This is the command for controlling the OVN northbound database. This only works on the host where OVN is installed. Similar, OVN southbound control. This is the command for controlling the OVN southbound database. OVN, OVS OpenFlow control and OVS application control. This one, the first one, is used for controlling open flows. The second one is for controlling the open vSwitch daemons. And now let's go over to the demo. I will first go to our central server and install the provider. I don't have the RPMs ready, so I will start with cloning the repo. It shouldn't take long. Yes, it's done. Let us now go to the created repo and make the RPMs. Our RPMs should be now ready in the RPM build directory. Let us go there. As we can see, we have the oVirt provider OVN and oVirt provider OVN driver RPMs ready, freshly built just 1 minute ago. So let's continue and let's install the provider. Okay, the provider is now installed. Actually, it wasn't installed; it was upgraded, as I had a previous version of the provider installed. We can go over to a host now. I don't have the repo here, neither the RPMs, so let me just repeat the process. Okay, the repo is downloaded, so let me go into it and build the RPMs. The RPMs are ready in the RPM build directory. Also fresh, just built. So let me install this. This is a host, so we'll be installing the OVN, the provider driver RPM. We can see that the RPM is installed. OVN has been pre-installed on this system, so I skipped this step. Also, I have two other hosts in my system, both of them pre-installed with both OVN and the provider driver. We can run the OVS ESCTL command to check if the integration bridge exists on this host. As we can see, we have the BR int bridge, which is the OVN integration bridge. Let's go over to the central server. We can check we can check if the state of the southbound database and check if all the hosts are added to it. We have all 3 chassis. Actually, I should also run the VDSM tool on it with first the ID of the OVN central and the local IP used for tunneling. But since I already had the driver installed in the system before, I also had, oops, something wrong. It should be OVN config. I had the driver installed on this host before, so my OVN was already configured. If we run the obvious vSwitch control command again, we will be able to see that the integration bridge has 3 ports already added to it. These are the tunnels, 2 tunnels to the other hosts, one ending with 43, one with 44, and we have the internal BR-int bridge. Let's check on the state of the northbound database, which is the logical state of our system. It doesn't show anything as we don't have any logical switches in the system yet. Now, let's go over to the oVirt UI. We will now add a provider to our system. We go to the external providers menu, click add. We must give a name to our provider. The type of the provider is external network provider. The provider is installed on the same host as oVirt engine, so the local host URL is correct here. We also want to uncheck the read-only option. Leaving it as read-only will not allow any modifications like creating, editing, or deleting networks and subnets. So if we want to create any external networks on this provider, we must uncheck it. If it's read-only, we always have the option of importing the external networks. By clicking the test button, we can check the connectivity to our provider. As we can see, the test succeeded. So let us add the provider to our system. In the network subtab of the provider, we can view the external networks. We can import the networks. As we see currently, there are none, so we cannot import anything. Let us create an external network now. To create a network on an external provider, we must check the Create on External Provider checkbox. We will get a list of our external providers. Currently, we only have this one. We must give our network a name. Let's call it OVN net and click OK. The network was created. Let us go to our OVN central. I will repeat the OVN northbound control show command, and let us see if a logical switch with the corresponding name was added. As we can see, there is a switch called OVN net. So far, it's only the switch. No logical ports have been added to it. Let us now create some NICs and connect them to the external networks. To do this, I will go over to my virtual machines. I have one on one host, the other VM on a different host. Let me go over to the network interfaces. And I will create a new network interface assigned to our external OVN network, OVN Net1. I want it to be plugged. Let's create it. And now let's create another port on a second VM on a different host. I choose the external network, which we have just created. The port was created. Now, let us look at the state of our northbound database. You can see that 2 logical ports have been added to the OVN net logical switch. I will now check what happened on the hosts on the local OVS bridges. We can see that on the first host, besides the tunnels which we had previously and the local BRINT port, we have one additional VNet1 port. The same should be true for the other host. Here we also have the BRINT port, the 2 tunnel ports, and an additional port VNet0. We should also be able to see this in the southbound database. Typo. And we see that on host 43, we have one port binding. On host F44, we have another one. On the single host to which we haven't added anything, there is no port binding at all. What else we can check is the open flows that were created as a result of our actions. Now, this is the view of the open flows is a little bit complicated. There will be quite a lot of them, so I will not go into the details. But if you like to analyze them on your own, this is the command to get them. We want not a dump flow, we want to dump the flow, and we want to do it for our integration bridge. As we can see, the number of open flows created by OVN is quite big, but I can assure you that this works. What if anything should go wrong? I hope it doesn't, but if you need any troubleshooting, here is the location of the most important logs. The provider log is located in var log oVirt provider ovn.log. The VIF driver logs, there is actually no special log file for this. We use the VDSM log for this, located in var log VDSM vdsm.log. You can look at the OVS logs located in var log open vSwitch. Also, if you want to check the state of the northbound database, instead of looking the OVN northbound show command, you can look at, you can use the tech command of the provider. This will dump the state of the northbound database for you. As we can see in the networks, we have our OVN Net1 network, and we also have the ports which we have created. These contain somewhat more information than OVN, as it also contains the oVirt related data, like, for example, device IDs, the oVirt device IDs. Some troubleshooting. Until now, the most popular cause of problems was first, incorrect setup of the firewalls. Please check if it has been set up properly. One is the firewall setup for the provider. The other is the firewall setup for OVN. The second most popular issue is a problem with setting up the OVN tunnels. If you cannot get pings between your virtual NICs created with the OVN provider, please check if your tunnels are up. Without it, it will not work. This is the end of the presentation. If you have any questions, please feel welcome to ask me by email or on the oVirt channel. Thank you for listening. Bye-bye.